And good morning again. So now we have in 11.5, you can see we have what? We have an area. Area of what? Area of polar. As well, we have a length. We remember the length before we got something about the length. We have a dx delta x square, if you remember that. We say for length. For length, we say L is equal to integral A to B, if you remember in the 11.3, I think. No, 11.2. And we say the square root delta x square plus delta y square dt. And we know this delta is what? Dx over dt square plus dy over dt square, then dt from A to B, where t is between A and B. Here, before we are going to area or talking about area, I am going to talk about the length, then we will back to the area. You can see from here, length of polar, okay? Length of polar is equal to what? R square dr d theta square d theta. So change the same, alpha and beta. Instead of t, we have alpha and beta, okay? And instead of dx and dy, we have what? We have r squared. So the rule changed to from alpha to beta, okay? Square root of r squared dr over d theta square d theta. So we are going to solve this. That's between alpha and beta. We are going to solve this integral to get the length of polar. For example, if I'm asking about, you have an example here. We have 1 minus cosine theta, 1 minus r طبعا equal to 1 minus cosine theta. So how we find the length? We say r square is equal to here square, right? Sorry, cosine theta. Then dr equal to what? dr over d theta is equal to what? Derivative of here equal to 0 minus derivative of cosine minus sine, minus multiply minus sine theta. And then we are going to put this one as a square to put under the square root. So we say L is equal to, we know 1 minus cosine theta will be instructed from where to where? From 0 to 2 pi. So theta between 0 and 2 pi. So now everything is ready. We say L is equal to from 0 alpha beta, okay, integral, square root of r squared. R is what? 1 minus cosine theta square plus dr d theta square d theta. And I know this one is equal to what? Sine of theta, as we mentioned here. So that's all that we have. And we try to solve this one by opening or expanding this complete square, and you'll get what? 1 minus 2 cosine theta, am I right? Plus cosine square of theta sine of theta square, sorry, d theta. And that one we know is equal to 1. And we will get what? We will get 2 minus 2 cosine theta d theta from 0 to 2 pi. So L equal to that one. And we mentioned in calculus 1, also in chapter 8, many times how to eliminate square root by using double angle or multiplying by conjugate, and you'll get the result. You can see from here. Here's the result. You can use double angle or using conjugate, up to you. So you'll get that one and you solve the rest of the example. I'm not going actually to solve the integral for you. It's easy. I know you so many kinds of that one. So this is about the length, because in 11.5, we should cover two subjects, two important things. One of them is length. So we covered length. Now it's time to what? Time to talk about area. Before going to area, do you have any question about the length? It's just you have a rule and put it. Clear, students? Clear, dears? Good for you. So now the important things. I don't say length is not important, but actually in this section, area is very, very important. So the important things here, we can see area of polar. So area is two parts. One curve or single curve or between curves. Especially we can say double curve or two curves. Understood? Maybe single or one. Okay. So both of them, they have a same rule, but with a little bit different things. Area generally is equal to, from alpha beta, 1/2 r squared d theta. That's the first rule for the single part. And if we have a curve here like that, if we have a curve, we have the same rule. We say a equal to 1 in alpha beta 1/2, but r2 square, or you can say r1 in here, up to you. I don't know in the book it's right r1 or r2 because it does not make a change, but it's a renaming. So you say r2 square minus r1 square d theta. Careful from here, separately square, not a bracket square, not a parenthesis square, so careful. So now we are going to talk about the first part, then later we are going to talk about second part. Do not forget about the area in polar. We have two cases, single and double. Okay. So for single, we say the rule is what? A equal to alpha beta 1/2 r squared d theta. Okay. Example to understand. And here's talking about how to find the area actually here. How to find area. The first angle that we, for example, we have a shadow. We try to find the area of here. This part. So we have an angle, starting angle, and we have terminal or last angle, beta, because we need to find the area of here. So we have a alpha and beta. And also we have a r. How we sketch the r? We see the r start from the origin to the end of the curve to here. So r is that length. R is that period, that duration. Understood here? Okay. To give you more clue, I'm going to solve an example for you. So actually this is about the theoretical how to find it, and this is the rule how to find the area. Here we are, we have what? Find the area of the region in the extra enclosed by, enclosed by what? Cardioid, or maybe he said just enclosed by that one without mentioning anything. So find the area of r equal to 2 minus 2 cosine theta, right? Understood? So how we find that one? Before you are doing anything, sketch the graph. And you know how to do it. So we have that one from 0 to pi. Here's 2. Here's what? 4, am I right? But the important thing is where? How we sketch it. Start from here, 0 to there. We can answer this question, or also here, like that. We can answer this question as a equal to 1/2 from 0 to 2 pi whole curve, okay, because we need the area enclosed in the heart, in the cardioid shape, okay? So r squared d theta. Understood? This is the first way. The second way is what? Can you give me the alternative area? Thank you. Yes, exactly. But we multiply by what? By 2. Why? Because the symmetry about x-axis. And we know that sketching the graph. So if I find that this part, and we multiply by 2, of course, I'll get the double areas I needed. Understood here? So that one, in that case, you can use both of them. Both cases are easy to find them. So I'm going to find them as any way that we mentioned. So maybe from 0 to 2 pi, 1 over 2, 2 minus 2 cosine theta, all of them square, d theta. Okay, this is the area that I want. So equal to 1 over 2 is coming to out, and I'll get what? From 0 to 2 pi, first square minus second multiply the second, am I right? First 2, 4, 8 cosine theta plus 4 cosine theta square and d theta. And actually, I'm not going to solve that area, that integral again for you, because we made many, we solved many. So you can see from here, everything is clear, and we know how to find them. Any question about the method? Did you understand? For example, during the exam, if I say find the sine, for example, I say r equal to 3 minus 2 sine of theta, I think it's easy for you. You know how to sketch it, right? Good. Because of symmetry about y-axis, and you know from pi over 2 to minus pi over 2, or from pi over 2 to 3 pi over 2, and you'll get the result. Okay. Any question about the single part? No? Good. So we are going to the double, means that area of the region between curves. We have two curves. Look at here. This is the first one, this is the second one, and we try to find the area, this area. So how? We need the alpha, we need the beta, and also we need to find R1 and R2, because we have R2 square minus. Before we are going to solve, I'm talking, let me give you the example, then we are going to talk about it. Look at the example. Say what? Find the area of the region, okay, that lies inside the circle, r equal to 1, and outside the cardioid r equal to -1 and -3. The important thing is to read the question actually many times to get the region after sketching. So in the exam, I don't mention circle, and I am not mentioning cardioid because you know about the name, and just do it. So we have what? Find the area that lies inside r equal to 1. In 11.3, we mentioned that r equal to 1 is the circle. So we have r equal to 1. And he say what? Inside, right? Inside that one. So inside means that here, everywhere. Am I right? And we have another condition. And what? Outside of what? And outside of what? R equal to 1 minus cosine theta. I know it's the cardioid, and it's like that. Yeah, so which part is part? Outside is where? Am I right? Inside the green one, the circle. Outside what? The red one, the cardioid. Do you have any question? Understood. So what is the specific area that I want to find? If I sketch in both of them, where's the specific area that I want to find? Sure, it will be here. Am I right? Why? Because it's the intersection region between the other one and the other one. So inside and outside. So that one is not. Why? Because it's inside the cardioid. That one, no, but that one is yes. You can see from here. You can find the intersection area. That one, just the intersection area inside the circle and outside the cardioid. Do you have any problem with the highlighted part, yellow part? Hello? Because if you don't know how to sketch it, if you don't know what's a specific area, you cannot find them. Clear, dears? Good. So now, in my mind, this is important, and that one is important. I know here is equal to what? Huh? Here is equal to what as angle. So my region is that angle to that angle. Am I right? From here to here. So alpha is equal to what? 1 angle. Pi over 2. How about here is equal to what? We have this region. Wait. We have this region is shared between them, right? We see that in the yellow. So this region start from here till where? Till here. Am I right? Come on, pi. Just pi. So I need alpha and beta. I say area is equal to 1 over 2. Sorry. R2 square minus R1 square d theta. Okay, forget about R. Now about alpha and beta. So I should write what? Alpha is 3 pi over 2, okay? I don't know. من هلا نسيمه تمام كيف بيتا اتوانم كيف الفا just why نسيمه بو بزام شتغليت يبغن pi over 2. Any question? Do you have any question? Are you sure about that one? Yes? No. Minus pi over 2 is more accurate. Why? Exactly. Okay. Exactly. Because when you say 3 pi over 2 means what? Means what? بعدين شو حسابكم اليوم كم ايه حسابكم means that from we are going to here to there, then from there to here. It's not accurate 100%. But if I say minus pi over 2 and pi over 2 means that from here to there and here to there, what's our objective? What's our region actually? And you can see from here. Okay. Any point about that one? Between here, look here. So we need, sorry. We need from here to there. So if you say alpha, you can say is equal to what? Pi over 2 by a minus. If you say beta, as you mentioned, it's clear, pi over 2. Basha, why is not from pi over 2? Why I cannot write like that? Pi over 2 to 3 pi over 2, Jamaat. Exactly, it's here. Means that we are talking about here, right? So it's not our region. That's why we are going to talk about what? Talk about minus pi over 2 and pi over 2. Understood? And usually here should be less than. Here should be smaller than the upper lower bound. Okay? Kaka? Lower bound should be smaller than upper bound. Understood? So that's why we are going to select minus pi over 2 to pi over 2. If somebody say, I have a region from minus pi over 2 to pi over 2, directly you see it's from here to here without thinking, right? Good. Now, tell me about R1 and R2. So you have two duties here. Tell me about tan 1 over 2 d theta. R2 square minus R1 square. What's R2 and what's R1? We say that we are going to sketch the line from origin to pass our region. So now I am going to do it like that. Okay? From origin to pass our region. Here's my region. Here's my region. Let me highlight it. This is our region, you know. Okay. Okay, then the first one, entrance, will be R1. The leave will be R2. So the curve of that one is what? R1, R2. How about this? That one will be R1. Am I right? Understood? That one, entrance, will be R1. Leave will be R2, the curve. So that one, R2 is equal to 1. How about R1 equal to, I don't know, 1 minus cosine theta. Am I right? Shall I repeat that one? We have a curve. I'm going to anywhere. You are free, feel free to sketch any line, any arrow. The first one will be R1, the second one will be R2. So I'm going to put the equation. I see that one, the equation of R, the circle. So R2 is equal to 1. And the equation of that one is what? R1 is equal to 1 minus cosine theta. And I'm going to put it here. So that's why I say R2 will be 1 square. R1 will be what? 1 minus cosine theta square. D theta. I'm 1 over 2. Take 2 out. Pi over 2 minus pi over 2 area. If I have, for example, two regions. Say that one, R1 equal to 1. R2 equal to 2. Let me like that, okay? We don't say R1, R2. Sorry for here. Just we have RR. So when you try to find R2 minus R1 from, here's your region. From the origin, I'm going to sketch or drawing a row. Then that one will be entrance, that one will be leave. That one will be entrance, that one will be leave. So I say that leave here's R2 and the entrance here R1. You got it now? Hello? So for example, in this example, the previous one, if I am talking about that region, find the area of that region. So how's R1, R2? Can you imagine? From origin to my region. That one will be R1. That one will be R2. So R1 here is what? 1. R2 is equal to what? 1 minus cosine theta. Did you understand? I changed it. Depending on the region. Depending on the region, you are drawing a row from origin to pass your region that we mentioned it. The first line that you intersect will be or the entrance, it will be the R1, and the biggest one will be R2 that we leave it in the region. Clear, right? Understood, Jamaat? That one changed. Why? Because we changed the region. Here's R2, big one, and that one R1. Question? No question? So here we are. We say from area equal to 1 over 2 generally, from minus pi over 2 to pi over 2, R2 1 minus R1 d theta. And let me give you some common mistake that students do it. Do not write like that, Kaka. That one is something else. Understood? R2 square minus R1 square, not R2 minus R1 square. That one not equal to, you know. So careful. The rule is like that, not like that. Understood? Good. So look at here. And can you give me another area, alternative area, instead of here? Instead of here to there. Can you mention another one? Instead of saying A equal to 1 over 2 from minus pi over 2 to pi over 2, and can you change that one? Sign, no. Just change the boundary, I mean. Give me the alternative for boundary. Right? Easy. Look at the picture. Instead of here to here, can you give me something else? Yes? Huh? No, just here, just here. Yes, you are right. Another one, 0 to pi over 2, right? Well done. Negative pi over 2 to 0. We can find here, we multiply by 2, or from 0 to pi over 2. Because why? Because both of them, the circle, if you find this area, is equal to that area, right? And also for the cardioid, if you find there, it will be equal to here. That's why in both cases, you can say 2 multiply pi over 2. Am I right? Multiply 1 over 2 R2 square minus R1 square d theta. So we can play with it. It's not one way. It's not like just you should pi my, no. Depends on your, yes, depends on your idea. And none of them is wrong. Minus pi over 2 pi over 2, 0 to pi over 2, the same. No, we can't. Why? Because the area, actually he asked a good question. Because the area is from where? If you say pi over 4 means that you just count here. How about that part? Understood? No, maybe it's not equal 100% because you have a curve here. So careful. Understood, Kaka? Good. Now here we are, R2, R1, and go on. From 0 to here, 2 multiply pi over 2, and go on, and you get the result. You can see from here, it's clear, like a cusp, like a something here. And from 0 to here, R1, R2. From 0 to here, R1, R2. Let me do a sketch in another line, the same. Another line, the same. Another line, the same. Does not make a change because the rule is the rule, right, for everywhere. Understood? Hello? Good. Forget about that one. It's talking about point intersecting. Actually, not forgetting, sorry. It's important, but let me, yeah, the last one. So I thought there's another example. No, we finished. Okay. So let me give you some information about here, example 3. Example 3 will help you to solve or to understand at least 9, 10, 11, or all of them. But these are important, these three. To understand these three is very important. So we need to information or some idea in example 3. Okay. I'm going to calculus 1, or at least let me go to the college in high school. In high school. Okay? Because if you forget it, let me review it for you, give you the basic. When we say y equal to x plus 1, you know, we have what? This is the equation of line. Am I right? X plus 1 means that like that. Am I right? Understood? Right? When we say L2 is equal to y equal to 1 minus x, we have something like that. Am I right? Understood? So this is L1, that one's L2. Or no, L1 and L2. Okay. So how we find this intersection? My idea is what? I have L1, I have an equation. And I have L2, another, we have, sorry, not equation, function. We have another L2 function, or linear line, or linear, or line. So how we find L1 and L2? Intersection between them. We equal them together? Thank you very much. We just make them equal. So let L1 be equal to L2. So we see y equal to, for example, the first example was x plus 1, that be equal to 1 minus x. Am I right? Good. So in that case, you'll get what? 2x. Am I right? Equal to what? To 0. X is equal to what? To 0. We find x. So how about the second point? Put in L1 or L2. You get what? You say y equal to x plus 1. Am I right? So you get what? Y equal to what? 1. Am I right? Good. So 0 and 1 is intersection point. Means that I have two lines. They intersect at 0 and 1. 0 on x-axis, 1 on y-axis. So if I have a line and I want to find the intersection point, it's true. If I want to find the intersection between this pen that I have with my paper in one point, so how we find them? We are bringing the equation of the plane. I have a plane, right? Not line. And with the equation of this line, actually that one is very important for Cal 3, advanced calculus that you have. Give you many things in the geometry of here, vectors. I know some of you, they don't have it, but for the others is good. So if you want to find the intersection between this line and plane, you should try to equalize them to find the intersection point. For example, if you try to find intersection between, let me say, this plane and that plane, these two whiteboard, this plane and that plane, they have intersection, right? So how you find them? The intersection is equal to what? Instead of point, is equal to what? Line, right? To give you more clue. This is a plane, plane 1, P1. That was plane, P2. The intersection of this one, that is one line, right? So like that. Or maybe two planes, they are intersection in one line. So this is very important. To find such problem like that, we need to what? We need to find to equalize them. Then we find x and y and z, because we have x, y, and z there. We have 3 dimensions. So each point you find the x, you put it in y, you find y, you put it in z, and you find the result. Understood? Good. So the same thing is true for polar with some spice. It's not 100% here like that. You cannot say, if I have R1 equal to 1 minus cosine theta. And I have R2 is equal to, for example, 1 plus cosine theta. If I say R1 equal to R2, you will find some of the intersection point, not all, some. Intersection points, not all. The rest point, the rest intersection, you can find by graphing. So graph is very important. That's why you mentioned 11.4. Now we have what? Sometimes, in your exercise, sometimes we can find by equalizing, we will get all, and sometimes no. So you should be careful. Understood? That's the difference between polar and the XY plane, Cartesian coordinates. Polar coordinates and Cartesian coordinates. So I'm going to find this one is R equal to what? R equal to 2 cosine pi over 3 intersect pi over 2. So we have 2 R equal to 2 cosine pi over 3. Find the point, intersect with what? With R equal to 2. We say R1, R2. We are going to make them as equal. So we say 2 cosine 3 equal to what? To 2. And by 2, you'll get what? Cosine pi over 3 equal to 1. Am I right? Hello? Yalla. After that one, how I find cosine? Inverse, you are right. So pi over 3 equal to what? Cosine inverse of 1. Right? So equal to what? Afwan, sorry. I think it was square root of 2. So I'm going to fix it. Square root of 2. Square root of 2. So cosine theta over 3 equal to square root of 2 over 2. And theta over 3 equal to what? Cosine inverse of, and you saw that one. Plus what? Which angle is equal to, cosine is equal to pi over 2 over 2? I gave you the table. Pi over 4. Okay. So theta over 3 equal to pi over 3. So theta is equal to what? 3 pi over 4. Am I right? So 3 pi over 4. 3 pi over 4, you know, is equal to what? To some angle here. 135. Am I right? 90 and 45, 135. Well, pi over 4, 45. 2 pi over 4, 90. 3 pi over 4, 90 something. 135. Do you have any problem? So how many points do we find them? 1 point, right? We found just 1 point. But you know, the curve is square root of 2, and the other, what was what? The other curve, 2 cosine of pi over 3. We saw that is like a cardioid, but in the outside. So you have this shape. Sorry, here's the intersection. Let me do it here. You can see from here. So it remains many points. So how you find the other one? If you know the graph is easy. If you don't know the graph, how you solve the other one? How we find the other points? Last thing. Last person. So how we find that point? We find that point. You are right. Square root of 2, 3 pi over 4. So, and I know there's another intersection because I have a sign. Sign is a symmetry about x-axis. I know there's another point. Yalla. How do you, what do you mean? Sorry? Negative of what? The same here. Negative of here. Why? Yes, the symmetry and cosine is the even function. Sometimes the cosine will make a negative here. You can see if you imagine. Sorry. We say we can put a minus here. Why? Because cosine is even function. Sometimes forgetting or eliminating minus. That's why I say minus. That's why I say minus. And I'll get minus, which is equal to what? 5 pi over 3. You can see from here. You can see, say we will get negative, and in the negative value, we will get what? 3 pi over 3 or 9 pi over 4. And the result will be what? 5 pi over 4. Why? I couldn't get it actually. Why? No, not about the boundary. It's not about taking the integral. Just find the endpoint. We don't care about the integral. Why we say pi plus pi over 4. Why? I think I left that one as a homework for you, right? We say find the value. We mentioned something here. Then we see let's here be homework and homework and homework. Am I right? So that was a homework for you before. Sometimes we see this angle is equal to what? Pi plus this angle here in the third quadrant. Yeah. So if I have a pi over 4 here, means that I have pi over 4 here. That's equal to 5 pi over 3. Do you have any question? And we talk about the length. Do you have any question? Let me stop the recording.